So we want to find the tangential and normal components of acceleration. Use your work from number 4 on 13.3. So A is cool. So A, so I think what you're meant to do here is look up what your answer is on number 4 on 13.3. So it looks like for part A, for some reason I wrote n of t first, but it looks like n of t is negative cosine tj plus sine tk. So you know what I'll do? I'll just copy these guys in there. So what I'm saying here, I'm trying to make this user-friendly. Don't do all this work over again, right? So this is the answer that you're supposed to look up, either from what I posted or from what you got in your own homework. And then if you want the tangential component of acceleration, which we call a sub t, well, what's a handy formula for that? Which is a dotted with a dot t. Yeah. So guess what? The hardest thing about this problem is reading my handwriting. I'm guessing that says minus cosine tk right there. We've got t. We can get a easily enough, right? So let's get a by taking, well, first of all, v of t, which is r prime. So v of t is going to be, what is that going to be, guys? 2i sine tj minus cosine tk. And then a of t is going to be what? Oh, that's nice. 0i minus or plus? We're just taking derivatives, so how about minus? Cosine tj, and then, yeah, then it'll be plus, right? Plus sine t. Okay? Or if it helps you to think in component form, 0, negative cosine t, sine t, right? Because when you're taking a dot product, it's kind of helpful to think in component form, just so you don't forget about that 0, right? So what are we going to do then? Well, what are the components of this guy? By the way, what can you do with the 1 over rad 5? Well, it's not really called distribution, scalar multiplication. It looks like distribution. You're right, it does. And that's why the notation's used, right? Because it looks like distribution. I don't recommend that, though. You can leave it on the outside. And then it's easier to do the dot product. There's less of a mess in there. You can take the dot product. You can leave the times the scalar on the outside and do the dot product of the two vectors. So the components are 2 negative sine t and negative cosine t, if I can read my own handwriting. So the idea then is to take, don't forget, to leave the 1 over rad 5 out front, and then take the dot product of these two vectors. So this guy times this guy, 0. Okay, big set of parentheses, 0. And then this guy times this guy, plus, yeah, it doesn't matter what order. So sine t, cosine t, right? And then this guy times this guy, minus sine t, cosine t. And then what's all that going to be? 0, yeah. I suppose all the acceleration is in the turn, right? So it's not, there's no straight line acceleration going on here. It's all in the turn. And that kind of makes sense because anybody remember what this graph's to be? Might graph to be a helix, right? The helix, all it's doing is turning, right? It's a corkscrew.